Today's screencast is about the chemistry of fire, so the chemical background as it applies to what you would learn in chemistry class of fires. This is the fire triangle, the three things that a fire needs in order to burn: fuel, oxygen, and heat. So the fuel obviously is wood, lighter fluid, paper, things like that. Oxygen is obviously atmospheric. And then you need heat. You can have a pile of wood. It's just going to sit there. It's not going to spontaneously combust and burst into flames unless you have something, a heat source, that gets that fuel to the ignition point. So the heat would be in the form of a match or a lighter or something like that. So a fire is an example of a general type of reaction called an oxidation reaction. This is any process where a substance combines with oxygen to produce new substances. This reaction is what happens when we use the Bunsen burners, or you use your gas dryer at home, or a gas furnace at home. Methane is natural gas. In the presence of oxygen and heat, so methane is our fuel. If we have oxygen present and a heat source, then that methane is going to burn. And we always have the same products when we have a combustion reaction: carbon dioxide and water. Not all oxidation reactions are as spectacular as a combustion reaction. Rusting, iron rusting, is where iron combines with oxygen. There's no energy there. That's the missing component. Energy is the capacity to do work. This can be constructive work or destructive work. In the case of a fire, most of the time, if we're talking about a crime scene or a criminal investigation, it's a destructive form of work. The main concern of a forensic scientist or a fire investigator is fire itself. The energy of combustion is that initial energy that's required to get the fire going, the activation energy. Let me come back for a second so you see that for a little bit longer. Sorry. An exothermic reaction, if you look at the prefix exo, meaning out, and therm is the root of the word, meaning heat. Heat is being released in this reaction. So the heat of combustion is less than the heat given off during the reaction. Or if we talk about the starting heat and the final heat, the initial heat is less than the final heat. So like if you have hand warmers on a cold evening, that's an example of an exothermic reaction. Once you mix those reactants together, you get heat being released. An endothermic reaction is the opposite. The heat of combustion is greater than the heat given off. Initial heat is greater than final heat. Heat gets absorbed, like when you get a chemical ice pack. When you mix those components together, it draws in heat from the surroundings, and because of that, the area around that ice pack feels cold. Accelerants have to reach a certain ignition temperature, and that reaction rate of the fire also depends on temperature. Rusting occurs slowly at room temperature, but if the reaction mixture is heated, that'll speed up. Same thing with a fire. A fire will burn through wood faster when the wood is warmer, when it's hotter outside. The ambient temperature, surrounding temperature, is hotter than if it's colder. In fire investigation, the main objective is to find the point of origin, abbreviated POO, for your entertainment. How to find a POO. That's point of origin. You find the outer edges of a burn area and follow it back to its center, its hottest, longest burning place. You can determine the direction the fire moved based on burn patterns. So you find the area of greatest destruction. You can see a couple of examples here. The burn patterns on this left-hand side can kind of be traced back to this area right here. And you see it looks like this. There's a liquid that's been poured and that has been burned. And here, kind of in the center, you can see ashes and more destruction than around the outside. The next thing an investigator needs to do is find the cause of the fire. So the area has to be carefully examined, obviously, and searched for frayed electrical wires, odor or bottle of an accelerant, different things like that. Here you can see on the left a poured accelerant around the exterior. Got some frayed wires that shorted out here. And wind direction can be traced backwards, reverse, to narrow down the point of origin.